All right, last three examples of this section. So we're going to try to determine if the EVT applies on these. So this is yes, and the reason why is because f of x is continuous on this closed interval from -8 to 1. So the EVT applies, which says we have at least one maximum, absolute maximum, one absolute minimum. All right, these can occur at either the endpoints or they can occur at our critical values. All right, so if we're trying to find the critical values, all right, values, that's going to be where the derivative is 0 or where the derivative is undefined. All right, so let's find the derivative here. F prime of x equals 2 minus 2x to the negative 1/3 power. All right, another way of writing this, which might make it a little more clear, 2 over the cube root of x. So this is going to be undefined at x equals 0. So we'll add that to our possible list of candidates. All right, and then we're trying to figure out where could our derivative equal 0. All right, so I can move this to the other side. I can multiply by cube root of x, or divide by 2. So where would this equal 1 at? All right, and that would occur when x is positive 1, which we already have. So these are our only three candidates for this function. All right, if now all we have to do is plug them in. All right, so -8, if you plug that in, you get -28, I think. Plug in 1, you get -1, and plug in 0, you get 0. So which of these is the highest? 0, okay, so we have a maximum of 0 at x equals 0. The lowest of these numbers here, the y values, the minimum value is -28 at x equals -8. So there we go. That's all you have to do for these. Whoa. All right. Take that out. Trying to circle the answer. It didn't quite work out, but that's all right. All right. So let's continue. Example 11. First, does the EVT apply? Yes, the EVT applies. F of x is continuous on this closed interval from 0 to 3/2 pi. Next, don't forget to start your candidate list immediately. All right, we have our endpoints here, and we need to find our critical values. Critical values, remember, that's where your derivative is equal to 0 or it's undefined. So let's find the derivative. That'll be 2 times cosine of x minus, don't forget to use the chain rule here. Oh, actually, that's going to be a plus sine of 2x times 2. And I'm just going to write that up front. This is going to be defined everywhere. So there's no places where it's going to be undefined. All right. So we want this to be 0, so we could start solving this. All right, 2 times cosine of x plus 2 times sine of 2x. Where is that equal to 0 at? Well, let's divide everything by 2. All right, so when you are doing this, you would probably move one of these to the other side and try to figure it out. All right, but this might be easier if you remember. All right, sine of 2x, we could rewrite that as 2 sine of x times cosine x. So it looks like we would be making in our function a little bit stranger, but it's going to make it easier to solve. So instead of writing sine of 2x, I'm going to write plus 2 sine of x cosine of x. All right, so here comes the magic. Factor out a cosine. You get 1 plus 2 sine of x. All right, now you could just figure out where both of these equal 0. So where's cosine of x equals 0? And where's 2 sine of x equals 0? All right, this one's the easier one. Where's cosine equal to 0 at? So that would be at 1/2 pi. or 3/2 pi. So we need to put that in our list of candidates, 1/2 pi. And we already have 3/2, so we don't have to worry about that one. All right, this one I'm going to turn into another color just so we can differentiate it. Differentiate, get that joke? All right, 2 sine of x equals -1. Divide by 2, sine of x equals -1/2. Good thing you know your unit circle. All right, we have our pi over 6, pi over 4, pi over 3. And remember, these are 30, 45, and 60. All right. Where is sine equal to 1/2? So it's 3, 2, 1, 1, 2, 3. So sine equals 1/2 at these values, 1/2 or 1/6 pi, 5/6 pi, 7/6 pi, or 11/6 pi. Oops. But we're looking for where sine is -1/2. So you remember, of course, that all students take calculus. The only places where sine will be -1/2 is this, 7/6 pi and 11/6 pi. But look at our interval. All right, we're only looking for values up to 3/2 pi, so we can ignore this one. And then that brings our candidate, the only other candidate here. This would be x equals 7/6 pi. So to throw that over, put it into our function. Whoops. So f of 7/6 pi. So these two were our critical values. These were our endpoints. Plug them in. All right, f of 0 is just, let's see, it's 2 times sine of 0. F of 0 is -1. F of 3/2 pi, -1. F of 1/2 pi, 3. And the last one, f of 7/6 pi, is -1.5. So looking at these values, the highest one we have is 3. So there's a max of 3 at x equals 1/2 pi. And the lowest value we have, minimum of -1.5. All right, where did it go? We have a minimum value of, come on, all right, 1.5. Okay, well, I can't write right now, but you can still listen. I have a minimum value of 1.5, -1.5, at x equals 7/6 pi. So that's my absolute minimum. So we have one problem left, and this one will be a little bit different. All right, so for both of these, we can't use the extreme value theorem. All right, because we don't have a closed interval, and they're not continuous. All right, so I'm going to have to write really small, let's see. Our function here, we're going to do it by sketching their graphs. All right, find the extrema over the domain. So 1 over that. So this is going to be a really small area because there's a lot of places where it's undefined. If you want to figure out where it's undefined, we need this part to be greater than 0. Because if it is 0, all right, it's undefined. Let me erase that little dot. All right, there we go. If it is 0, the bottom, it's undefined. Sorry. All right. If it's negative on the inside of that square root, it's undefined. So the only place where this function exists are in between these values. So if you think about it, 4 minus x squared, hopefully you already know that, it looks like this. And it crosses the x-axis at -2 and at 2. All right, so the only place this function will be defined, all right, the only domain here is from -2 to 2, not including those values. So if we're going to graph this, there's only parts that are -2, from -2 to 2. And remember, we're not including those. So that's not going to be part of our extrema. Let's see. So it's going to look something like this. And you could do this by plugging in different values. All right, -1 is about 0.6. -1/2 is about 0.5. 0 is 1/2. All right, 1 is 0.6. So it looks like, and remember, these are open. Open. Okay, jump around. There we go. All right, these are open at the ends. So the only place we have a minimum value, we have a minimum value of 1/2 at x equals 0. And then we have this other function here. This looks like a fun graph because it's piecewise and we always have a lot of fun with that. When x is greater than 0, we have a slope of 1, or x is greater than 1, sorry. We have a slope of 1 and that is moved up to, oh, that's actually going to be a lot higher. All right, let's say like about here. This is this part of the graph. All right, 5 minus 2x squared. If we plug in 1, we get 5 minus 2, which is 3. If we plug in 1 down here, we get 3. So that actually fills in that hole right there. And we end up with this beautiful looking graph. All right, so find the extrema by sketching the graphs. All right, so if we had a closed interval here, we can assume that this point would be, we could say it's a relative max. It's not the absolute max because it goes on forever. It just keeps going up higher and higher. So we could say there's a relative max of, and when we put in 0, we get 5 at x equals 0. We could say we have a relative minimum value. All right, right at this point, we could say of 3 at x equals 1. All right, but we have no, oops, that's not no, that says now. All right, come on, there we go. We have no max or min, no absolute extrema here. Because if you look everywhere, it's not a closed interval. We can't check the endpoints. There's higher values than that top peak part right there. There's lower values than this. So there are technically no absolute or global maxes or mins, but there is a relative max of 5, all right, at the top of that hill, and there's a relative min of 3 at the bottom where those two parts meet. So this is all we're going to finish with, all right? Make sure you spend a little bit of time doing some practice, and I'll see you tomorrow or the next day of class.